All right, let's look at the 2015 AP Calculus exam. This was on ABNBC. This is number one. It's what I call a rate in, rate out question, and you will need a graphing calculator to answer probably every single part of this question. We'll see. So we have a drain pipe that is collecting rainwater on one end, and the other end is partially blocked, yet water is draining out. And they gave me the rate that water is going in and the rate that water is flowing out as separate functions. They're both fairly ugly, and I'll go ahead and make note on these rate in, rate out problems. The rate in is R of t. I have stored that in my calculator for F1. The rate out is D of t. I have stored that as F2. They tell me that at the beginning of the day, or at the beginning of this interval, there are 30 cubic feet of water in the pipe. And since they did not define a function to represent the amount of water in the pipe, they only gave me the rate in and rate out, I defined the amount of water in the pipe to be A of t. They tell me that the amount at time 0 is 30, and in these cases, the overall rate of change, A prime of t, will always be the rate in minus rate out. So I've gone ahead and defined A prime of t as well. That will most likely be used at some point. So moving on to the questions, A is asking how many cubic feet of water flow into the pipe on the interval, and notice they are only asking about what is going in. How much is leaking out is completely irrelevant. How much was in the pipe at the beginning of the day is completely irrelevant. We're only talking about what is flowing in, which is going to be dependent on the function R of t. And R is the rate in. So if I want the amount in, I'm going to have to do the antiderivative of R of t. I'm going to have to undo that rate by doing an antiderivative, and we will measure that antiderivative from 0 to 8. And because this is a calculator question, do not try to do this antiderivative by hand. You are expected to just throw this in the calculator and write down your answer. Alright, so we get 76.5703. Remember that on the AP Calculus exam, for the calculator portion, answers must be accurate to the third decimal. In this case, the third decimal is 0, and it would not round up because of the 3 that follows it. You must write that 0. My 5 is separated. You must write that 0 because that is the third decimal. If you don't write that 0, you will lose a point because you have not indicated what the third decimal is. So make sure you write the 0. It does ask how many cubic feet, so go ahead and include units. This would be measured in cubic feet. And there's our answer for part A. Number B is the amount of water in the pipe increasing or decreasing. And there are two ways to answer this one. The first way, and this is probably the way it is worked out if you look up the official College Board solutions, but the overall amount of water in the pipe will depend on both the rate in and the rate out. So what we could do is we could find the rate that water is going in at this time, which is 3, so I could find R of 3, and then I could find the rate that water is leaving. That would be D of t, D of 3, I mean. And we could simply compare their values. If the rate in is greater than the rate out, then the amount would increase. If the rate out is greater than the rate in, then the amount decreases. So we could simply compare the two values to get our answer that way. Okay, so the rates you get are 5.086 cubic feet per hour in and 5.4 cubic feet per hour out. D of 3 is greater than R of 3. The rate out is greater than the rate in. Therefore, the amount is decreasing. The amount is decreasing. All right, the other way we could do this one, and this is because I have defined the overall amount as A of t, and they are talking about the overall amount, is I could find A prime of 3, which I have defined the overall rate of change as R of t minus D of t. So A prime of 3 would be R of 3 minus D of 3, and if you do that, you will get an answer of negative 0.313. That is a negative value. If a derivative is negative, then that function is decreasing. Therefore, my overall amount is decreasing, and I am allowed to do it this way because when I first read the problem, I sketched some notes to myself, and among those notes, I defined A prime to be R minus D. So if you want to go this route, you have to define A prime somewhere in your work. For that reason, it's probably better to go with the way I worked in blue here, where you compare the rate in and rate out separately. Okay, then part C, fairly predictable question where they ask for the, in this case, the minimum, and it says at what time is the amount of water a minimum. We are on a closed interval, and so a minimum on a closed interval would be an extreme value theorem question where you want to consider all your candidates. So my candidates are my endpoints, which are t equals 0 and 8, and then my critical numbers for the overall rate of change. So we're talking about the overall amount of water. I need the critical numbers for the amount, which would be my function a prime of t, which I defined a long time ago. Set that equal to 0. A prime is r of t minus d of t. And if r of t minus d of t is equal to 0, we need r to equal d. And I can solve this in the calculator. I'm going to solve it graphically by finding their intersection point, and then I'll store whatever critical numbers we get. Okay, my critical number is 3.271. That is on the interval 0 to 8, and I have stored it in my calculator. Notice I made a note that A is equal to 3.271, and that is, I made that note because now I'm allowed to use the letter A instead of writing that value down. So to find my minimum, I now need to find the amounts at each of my candidates. My amount at time 0 was provided, and I can barely see that up there in the corner. It was 30 feet cubed. And my amount at my critical number, which I defined as time A, is going to be my initial amount, what I start with, plus the overall change from 0 to my time value of A of my A prime of t, which is r of t rate in minus rate out. So we'll find that, plug that in the calculator, and then we will find the final amount at time 8 by doing the exact same thing. 0 to 8, r of t minus d of t. And we'll slap those in the calculator to see when the minimum amount occurs. So my amounts are 27.9645 and 48.5436. And once I do this, I go back and I read the question to make sure that I answer it correctly. This problem is asking at what time is the amount of water a minimum. It's not asking for the minimum amount. So while I can see that the minimum amount is 27 point something feet cubed, the time that that occurs is 3.271 hours. So I'm going to present my answer as the minimum amount. Minimum amount occurs at t equals 3.271 hours. And there's your answer. You don't have to restate the amounts because it didn't ask. As for justification, in an extreme value theorem question, justification is showing that you considered all the candidates, your endpoints, your critical numbers, and that you found their actual amounts and compared the function values at those three candidates. So our justification is the work shown. You don't have to have a conclusive statement wrapping up an extreme value theorem question. Alright, so last one. The pipe can hold 50 cubic feet of water before overflowing. After t equals 8, water continues to flow into and out of the pipe at the given rates until the water begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w. Okay, so they defined a time w. Time is w when the pipe will begin to overflow. So what I am trying to find out is when is the overall amount of water equal to 50. So I've got to find the overall amount of water, and really they defined it as w. So they're saying that there is some time t equals w such that a of w will equal 50. What I have to do is figure out what is an expression to represent a of w, and the way I'm going to do that is the exact same way I computed my amounts in part C. To know my amount at time 3.271, I did 30 plus 0 to 3.271. For the amount at time 8, I did 0 to 8. And so I'm going to do the exact same thing. My amount at time W will be 30 plus the area, or the antiderivative, from 0 to W of rate in minus rate out dt. That antiderivative right there will give me my amount at time W, and I need that to equal 50. And they do say that my functions are still in operation, so we don't have to worry about resetting at time 8. They do say that even after 8, the water flows in and out at the same rate, so nothing has changed. So I can just go my initial amount, 30, plus 0 to W of this. There are a few other options, but this one's probably going to be the easiest and most direct because you can piggyback exactly on the work that we had for Part C. So there is your answer to all of the 2015 AP Cal number 1 question.